Hi everyone, my name is Sylvain Lézé from the Department of Aeronautics at Imperial College London, and this is the new episode of the podcast Turbulence at the Exascale. So if you're not familiar with the podcast, we are trying to gather the view of the scientific community here in the UK regarding the challenges and opportunities associated with exascale computing, with a focus on turbulent flows, but not only, of course. The main focus of the podcast is about high performance computing and the transition to exascale computing. So this podcast is part of the ExCALIBUR initiative, which is a big 5-year project here in the UK, where we are trying to redesign the software landscape in order to be ready for the transition to exascale computer, which will happen in a few years' time. This podcast is also part of the UK Turbulence Consortium. So today, our guest is Marion Weinzierl, who is a research software engineer at Durham University. She's also N8 RSC team leader, and we'll be talking about that. She's also part of the advanced research computing at Durham University. She has a lot of experience in different fields, including computer graphics, Monte Carlo methods, parallel multigrid methods, and so on, weather prediction. So it's going to be great to talk to Marion, as she's also heavily involved in the ExCALIBUR initiative. So good afternoon, Marion.
Hello. Thanks for having me.
Well, thank you very much for taking the time for this podcast. And I'm going to start with my first questions. For those who don't know you or may not know you very well, can you tell us a little bit more about yourself, where you are from, what you have studied, and how did you end up working at Durham University?
Yeah, sure. So I got my my first degree, my diploma, which is equivalent to a master degree in Germany from Ulm University in South Germany, and I studied actually media informatics, and then went from being involved in computer graphics and Monte Carlo simulations to do my final year project in applying Monte Carlo simulations to a real world problem, to solar energy systems, so fluorescent concentrators that you put in front of solar cells. And I went on to have a couple of months contract with the Fraunhofer Institute for Solar Energy Systems to basically wrap up that project and extend the simulation code that I had written for that. And then did a PhD at the Technical University of Munich in another simulation. And this time it was parallel multigrid methods for computational fluid dynamics. I did then a postdoc at Durham University in mathematical sciences and space weather prediction and solar magnetohydrodynamics. And after 3 years of postdoc, I went to industry in a local startup to work on X-ray imaging applications as a computational scientist, and then came back to Durham University as a research software engineer in advanced research computing.
Great.
And that's where I'm now.
Excellent. May I ask you, when did you become interested in computer science, in high performance computing, in programming, and so on?
So that's very different times I got interested in these kind of things. So in computer science and programming, so that was probably when I was still at school, and the first interest was probably sparked by special effects for movies and computer graphics, and also animated movies. So that's I studied media informatics. Then when I did my final year project with the Fraunhofer Institute, I got interested in scientific computing. And that is when I, for my PhD, looked into the field of scientific computing and got interested in computational fluid dynamics and its applications. And in the research group I worked in, where our building was actually, or is still next to the Leibniz Supercomputing Center in Munich. So a lot of people in our group already did supercomputing there, and that is when I then also started using supercomputers. And I think the interest really came mostly from the applications, and then moved towards high performance computing as such.
Great, thank you. May I ask you what's the best thing about your current job as research software engineer?
Yeah, so what I really like about what I'm doing currently is the variety of things that I'm involved in. So I do programming. I also give training courses and organize training courses. And then there's also the community work, working with other research software engineers, and the variety of people I work with. So working with the researchers, working with other research software engineers, working with platforms people and high performance computing. Yeah, I think it's really the thing of having so much variety in my work.
Great, thank you. And once again, for those who might not be familiar with your activities at Durham, can you tell us a little bit more about the N8 Center of Excellence in Computationally Intensive Research, and maybe also about the computer BD?
Yeah, N8 CIR belongs to N8, which is the consortium of the 8 most research-intensive universities in the north of England. And N8 CIR actually came from N8 HPC, which had the supercomputer Polaris, and was then basically transformed into N8 CIR, where we want to support basically all researchers and computationally intensive research, and particularly also those from non-traditional computational fields. Like, for example, we have a theme on digital health and also digital humanities. And the theme leads, so the research software engineering theme leads and the research infrastructure engineering theme lead work with representatives of each of the universities in these fields on what we can do to support their research. We offer lots of training courses and workshops, and another part of my activity there is also to organize meetings for the RSE leaders, RSE meetups, and as well, and so have a community of RSEs there as well. I'm also co-lead of the BEAT support group. So BEAT is our tier 2 supercomputer in the N8, which is located in Durham. And we have from each of the 8 universities a BEAT RSE who supports their users at their university, but we also have things that we do together in the BEAT support group, like looking after the documentation, looking into special applications that need some additional support on BEAT, and especially at this Power 9 architecture, so non-traditional computing architecture. So the users need some support also in importing their software there. And yeah, I forgot to mention that it's a GPU machine. So we're now actually also launching our new machine learning theme and trying to support the machine learning community in using BEAT, but also generally in the research in the N8.
Great. Sorry, I have a follow-up question. You might not have the answer, but how many users do you have roughly on your machines? Do you know?
I don't know. I'm sorry. So if I would have to plug a number out of the air, maybe 200 or so, but they are not all active users actually. So a lot of people get an account and then not use it for a long time.
Good. Sorry, thank you very much. Well, before I ask you some specific question about your role and your involvement in the ExCALIBUR project, I wanted to briefly talk about your involvement with the Women in HPC Initiative, and also with the Society of RSE that is quite active in the UK. So it would be good to hear your views on those two things.
Yeah, so Women in HPC, we've actually last year in NHCA, I applied to become a chapter of Women in High Performance Computing. So we have so we are now a chapter, and we wanted to launch our chapter in December at HPC Community Day in NHCAR, which unfortunately had to be cancelled due to COVID. But we've started work in there already. So our aim is to basically get a more diverse HPC community in the N8, and we're have several working groups working on things like EDI and recruitment and EDI and training and things like that, and are also in touch with the bigger women HPC community. For example, we hope to be running a workshop on the ISC, which is coming up in Hamburg, and things like that. So so that is one part that I'm working at in NHCIR as well. For the RSE Society, so I'm a trustee of the RSE Society since 1.5 years now. My term is coming to an end in October, so I've been working on various topics there. So I've been working on raising the awareness of the diversity of the RSE role as such. So I think a lot of people think about RSEs as sitting in central teams at a university supporting users, but we've got embedded RSEs who are often on postdoc positions in research groups. We have RSEs in industry, RSEs at, for example, the Hartree Center and other institutes. And so it's about making the research community aware of that and highlighting this, but we're also working on the career pathway and working with RSE leaders on basically collecting information on the career ladder for RSEs at universities, so that not everybody has to reinvent the wheel there. And so another part that I've been concentrating on for this term of my trusteeship is also EDIA, equity, diversity, inclusion, and accessibility, and improving that in the RSE society and also the RSE community as a larger. And I'm working with the EDI lead of the 2022 RSE conference, which is coming up in September as well, to make sure that it's diverse and accessible.
Great, thank you very much. I have another I have another question. I've seen some of your blogs that you have been contributing in the field of research software engineering, and I'm going to ask you a very direct question, but I think this is an important one maybe to discuss, is how do you engage research group leaders in sustainable software practices? And I'm asking this, I'm genuinely interested. Of course, I'm using software for my research, and there's a big issue around sustainability. So I'd like to hear your opinion on that.
Yeah, that's a difficult question because it's very much discussed. I think the answer has to be it depends. So it very much depends on the PI of the project. And if the PI is approaching a central RSE group, for example, and is interested in getting support, I think the RSEs will always bring up these topics, and we'll talk about version control, and we'll talk about testing and continuous integration and these kind of things. And the reaction that you get from research group leaders is very varied. So some are all for it and say, oh yeah, that's great. And so mostly they point to their PhD students and say, oh, please teach them. Rather than doing it themselves. But then you also have those that prioritize the research output and say, oh no, but now it's important to get out this paper. And so you basically, what all you can do is basically highlight the importance, and then maybe in your work already show the benefit of using version control of writing tests, and that you can actually save time even if you have to invest at the beginning. Generally, I think over the past years, it becomes clearer and clearer how important sustainable software is, and more people become aware of that. So I think by continuing to promote it in the society and at the universities, so hopefully people will see the importance. So, I mean, there was a big outcry last year. Was it last year or the year before, when it came to the COVID simulations, and there were some comments about the state the code was in, and so on. I think that raised some awareness on this topic as well.
Great, thank you very much. This is definitely a very, very important topic. Well, let's talk about exascale computing. And so my first question is, can you tell us about your involvement in the UK ExCALIBUR project? What are you involved in, and what are you doing within the ExCALIBUR?
Yeah, so I worked as an RSE on a project that came to an end of last year, which was called exascale, and which was about coupling the piano framework for solving PDEs to CLORPAC. Currently, I am involved in one of the cross-cutting projects on the tasking parallelism projects as a knowledge exchange coordinator, as KEC. So the KECs is actually an interesting concept. So they asked in the cross-cutting project that each project has to have a designated KEC. So somebody who's working on basically exchanging the knowledge between the projects, but also with a wider community. And so we meet once per month in this group and discuss about things that we can do and together. And one thing that we're currently trying to organize is we're working with the RSE Society on having a co-located workshop with the RSE conference, which will be in September. So we'll probably also partner up with the HPC champions, led by Andy Turner from EPCC, and have a workshop there where we talk about the ExCALIBUR project, but also about collaborating about our software, about the problems that we are facing, and so, and try to engage more with the wider RSE community there as well.
Great. I've seen also that you have been part of running a performance analysis workshop series, still within the ExCALIBUR project. So can you tell us a little bit more about those workshops?
Yes, that was an interesting workshop series, because it was a bit like a prolonged hackathon. So it ran over the first 7 months of last year, and we had 1 day basically per month. So we invited the developers of the performance analysis tools, and the concept was that we had research, our software group, so we had teams of people, so it was RSEs, it was researchers, and so from not only the UK but also Europe, and so who came there, and in the morning we had talks by the tool developers, so the tools were introduced and explained, and sometimes there was also a bit of a hands-on part in that part, and then in the afternoon the teams would go into their breakout room, so it was all online, and apply the tools to their software. So each team had to bring along one piece of research software they wanted to analyze, and the organizers and the tool developers then went around the breakout rooms to help the people to apply their tools. And then at the start of each of the new sessions, we basically had kind of a report back from a group or so and what they found out, and so, and then in the next session the next tool was introduced. So over the course of the workshop, so people could try out different performance analysis tools at their codes, and some actually got quite good insight and were able to actually improve their codes quite a lot. And then there were other teams that had a couple of issues in applying certain tools and might have gone better with another tool. Or we also talked a lot about, like, okay, why are we not able to do this now? Why can't we work with this specific code? And so what's the problem here? So we wrote actually quite a long report about this, which is on Zenodo, and all the insights that we had from this course. And then last December, we also had a follow-up workshop, so one morning with the people from POP HPC on general methodology and performance analysis.
Great, excellent. I have another question for you regarding the ExCALIBUR project. So the ExCALIBUR project is a 5-year project, and the main goal is to redesign or to prepare our software here in the UK for the transition to exascale. An important part of the project, of course, is related to research software engineering and training and preparing staff, students, to use exascale computers. So can you maybe comment a little bit about the RSE aspect of ExCALIBUR? What do you think of how research software engineering is taken into account within the ExCALIBUR project?
Yes, so I think EPSSE has been good in seeing the importance of research software engineering and research software engineers, and also making sure that RSEs are able to be co-eyes on grants, and of course there were the RSE fellowships, and RSEs can apply to the Open Plus fellowships now. And the ExCALIBUR program, there is the emphasis on RSEs, and we had one workshop with RSEs and PIs. To be very honest, I would have hoped that there would be a bit more in terms of having a discussion with RSEs on the same level. For example, there was the landscape review, the RSE landscape review, which was mainly written by researchers. So I think there were 1 or 2 RSEs involved, but given that it came out from this RSE workshop that was running, where we were basically divided into 2 groups, the PIs on one side and the RSEs in another breakout room, and then the PIs went away to write this this report. I would have hoped that there would have been more involvement by RSEs more in general, rather than being told what we have to be and what we have to learn there. Which is not to say EPSSE is doing a bad job, but I was a bit disappointed at that point, to be honest. But generally it's good to see that there are the opportunities and that there are grants like the RSE development grant, and that it's currently out, where hopefully more RSE training will be happening in the UK in the coming years. And and especially great is also the software for research communities grant, where we're currently waiting for the results coming back, and hopefully having further calls out soon.
Great, thank you very much. I have a couple of more questions, more general / philosophical questions. So my question is, if there is one thing that you could change about high performance computing, I'm not talking just about hardware, I'm talking about everything around high performance computing, what would you like to change? So it's a very difficult question, but I'd like to hear your view as research software engineer on this question.
So if it would be one free wish, it would be energy consumption. So that's one thing that I think is very concerning, how much energy is actually consumed by supercomputers. Chris Atzel gave a great talk, No Computing on a Dead Planet, in last year's RSE online conference. And yeah, it's very much to the point that yeah. So there's always this ethical question about, okay, so I'm running all this stuff and I'm making mistakes, and then I have to rerun everything again, and it's yeah, it's a big problem, I think, that there is in high performance computing. I think if we would be a bit more realistic, if it's not a free wish but something we need to work on, I think that if we become more aware of okay, how do we write our code, what can we improve, how can we be more performant, how can we be more efficient with our codes, and so that could be already a step into the correct direction, but obviously a lot has to be done on the hardware side as well as the software side.
Great, I fully agree with that. One last question. So there's a lot of discussion and talk these days about exascale, the exascale era that is already happening in China and will happen soon in the US and in Europe. But what about the long term? So where do you think HPC is heading in the future? I'm talking about in 20, 40 years. Do you think we are still going to be working with the same ecosystems, so on CPU, GPUs, and the same way we are working with Fortran and C code with MPI, or do you think we are going to have like some sort of a revolution with brand new hardware and brand new software and parallel padding? What's your view on that?
Difficult question.
Yes.
So yeah, so I think so. I would hope that we will have some novel technologies coming up, and hopefully people will be able and ready to embrace them and experiment with them. I feel at the moment people are a bit stuck and reluctant and like to stay with what they know and what's easy to use. So I think if we are able to make a step change in the usability of these systems and on that interface, then probably people would be more willing to also look into new hardware. I'm not a hardware expert. I don't know what will happen in 40 years there, but I would hope that on the software side of things, people will be able to work more on work better with the experts in software, so that the research people will be willing to listen to the software engineering experts and work with them towards better software and research. So yeah, I think it's hard to imagine what will be possible in 40 years. Sorry, I don't have a brilliant answer.
No, it was good to have your view on this. Thank you very much, Marion, for your time and for your inputs and for discussing about the ExCALIBUR project and your role as research software engineer. It was very nice. So thank you everyone for listening to this podcast. You will find all the recording on the UK Turbulence Consortium website. Just Google UK Turbulence. You will find us very easily. There's a tab ExCALIBUR with the list of all the podcasts. And of course, I will be putting everything on Twitter as usual, UK Turbulence on Google. You will find us very easily. So thank you very much, Marion, for your time.
Thank you.
And thank you everyone for listening, and I hope to see you soon in a new episode of this podcast. Bye-bye all.